Hello everyone, and welcome back to the Fluctus Channel. A full-blown amphibious assault usually begins long before troops actually hit the shoreline. Ships must position beyond the surf, crews must prepare vehicles, and landing craft must move heavy equipment from sea to land without relying on a port. The landing craft air cushion, or LCAC, performs this job by riding on a pressurized cushion of air. Its flexible skirt lifts the craft above the water, allowing it to cross waves, mud, sand, and many rough beaches that would stop a conventional landing boat. Inside an amphibious assault ship, the operation starts in the well deck. Vehicles are inspected, fuel levels checked, radios tested, and tie-down points prepared. An M1 Abrams tank or other heavy vehicle is guided slowly onto the LCAC's cargo deck, while deck crews use hand signals to keep its track centered. Once positioned, chains and tensioning devices secure the load against movement. The craft's operators verify weight distribution because an uneven load can affect stability, skirt clearance, and steering. To launch, the ship floods its well deck until the LCAC can float free. Gas turbine engines come alive, lift fans inflate the skirt, and propellers begin pushing air behind the craft. Deck personnel remove final restraints and signal the pilot forward. The LCAC slides away from the ship, clears the stern gate, and accelerates toward open water. During Exercise Bold Alligator in 2014, two LCACs departed USS Kearsarge off the eastern United States as part of a multinational amphibious exercise. Unlike a displacement hull, the hovercraft does not cut deeply through the sea. It skims above it, using lift to reduce contact with the surface. This allows speeds of roughly 40 knots while carrying troops, trucks, artillery, engineering equipment, or armored vehicles. It also means vehicles that cannot swim can still arrive during the first waves of an assault. Approaching the beach, the pilot studies surf, obstacles, slope, and traffic. The craft aligns with the selected landing lane, reduces speed, and crosses the surf zone with its cushion maintained. Spray engulfs the deck as the bow rises over the final waves. Once ashore, the LCAC continues across sand until it reaches firm ground. The bow ramp lowers, tie-downs are removed, and Marines guide vehicles off in sequence. During RIMPAC 2012 in Hawaii, LCACs departed USS Essex and delivered Marines and equipment to the beach. That exercise brought together 22 nations, more than 40 ships and submarines, over 200 aircraft, and approximately 25,000 personnel. The landing demonstrated why amphibious forces practice coordination on such a large scale. One delayed craft can disrupt the movement of vehicles, infantry, engineers, and follow-on supplies. Heavy armor requires especially careful handling. After an M1 tank rolls down the ramp, its crew immediately clears the landing zone so the LCAC can unload additional cargo or return to sea. Tank crews check communications, orient weapons safely, and form with supporting vehicles before moving inland. Similar training during Sangyong placed Marine tanks ashore from amphibious shipping, linking naval movement directly to ground combat power. LCAC operations can also begin from expeditionary transfer docks. These ships create an offshore logistics point where cargo can move from strategic seal lift vessels onto landing craft without a developed harbor. The LCAC approaches the transfer platform, settles into position, receives vehicles or containers, and then carries them toward the beach. This arrangement extends amphibious access to coastlines where ports are damaged, unavailable, or politically restricted. The next wave no longer depends entirely on tracked amphibious vehicles. The Marine Corps Amphibious Combat Vehicle, or ACV, is an 8-wheeled armored vehicle designed to carry Marines from ship to shore and then continue inland. Before crews venture to sea, they train. Instructors teach starting procedures, steering, emergency actions, communications, troop loading, and maintenance. Marines inspect hatches, bilge systems, seals, tire pressure, propulsion components, and safety equipment. They also practice crew coordination because the vehicle, commander, driver, and gunners must exchange information quickly when visibility is poor or waves strike the hull. Launching from an amphibious ship requires close cooperation between sailors and Marines. The ship lowers water into the well deck, creating a protected internal basin. ACVs start their engines, release tie-down chains, and move toward the stern under signals from deck personnel. One vehicle enters the water at a time, its wheels disappearing as the hull begins to float. The driver engages the water propulsion system, establishes steering control, and clears the ship so the next vehicle can launch. During April 2022, training aboard USS Macon Island in the Pacific, Marines from 3rd Assault Amphibian Battalion practiced entering and leaving the well deck. The 2-day event focused on safety, transport capability, and the development of tactics for future amphibious operations. These repetitions matter because the stern opening is narrow. Water inside the well deck can surge, and a stalled vehicle may block every vehicle waiting behind it. Once formed at sea, ACVs navigate toward the landing area in organized groups. Crews maintain spacing, monitor engine temperatures, and report position by radio. During Balikatan 2024 in the Philippines, Marines conducted waterborne gunnery while the vehicles maneuvered offshore. Gunners tracked targets from stabilized weapon stations as drivers held safe headings. Firing from a moving vehicle on water demands careful control because waves constantly change the angle between the weapon and the target. The assault advances when the vehicles cross the surf. Drivers select lanes, avoid obstacles, and maintain enough power to prevent the hull from turning sideways. As the wheels touch the bottom, the ACV transitions from floating to driving. Water pours away, tires gain traction, and the formation spreads across the beach. At Hwajin-ri, South Korea, in September 2024, Marines from Battalion Landing Team 1-5 used ACVs during exercise Sang-Yang 24 to conduct a simulated amphibious assault and secure the landing area alongside Republic of Korea forces. Securing the beach means more than simply arriving. ACVs move beyond the waterline, establish observation, protect exits, and deliver infantry where they can form defensive positions. Crews remain alert for obstacles, vehicles, and friendly troops while maintaining communication with ships offshore. The armored hull protects occupants from fragments and small arms threats, but speed and coordination remain essential because a congested beach becomes an easy target. Not every vehicle completes a mission under its own power. Launch and recovery drills teach crews how to respond when an ACV loses propulsion or suffers another failure at sea. A recovery vehicle approaches carefully. Lines are passed between crews and towing points are secured. Both drivers coordinate speed and direction while maintaining separation, so the disabled hull does not collide with the towing vehicle. Returning to the ship can be harder than leaving it. The towing pair must align with the stern gate, enter turbulent water behind the vessel, and move into the well deck without losing control. Sailors stand ready with lines, chocks, and emergency equipment. Once inside, the damaged ACV is secured and inspected. These drills ensure that one breakdown does not leave Marines stranded offshore or interrupt the return of the wider formation. Behind the landing force stands another class of ship designed to keep operations moving without a nearby port. Expeditionary sea base vessels, or ESBs, act as floating staging areas for aviation, small boats, special operations teams, equipment, and supplies. Derived from a commercial tanker hull design, an ESB has a broad flight deck, mission deck, hangars, cranes, workshops, berthing, medical spaces, and command facilities. It can remain offshore for extended periods during sustained military operations. USS Lewis B. Puller became the Navy's first purpose-built expeditionary sea base. Later ships, including USS Herschel, Woody Williams, USS Miguel Keith, and USS John L. Canley, expanded the concept. John L. Canley, commissioned as ESB-6, honors Marine Sergeant Major John Canley, who received the Medal of Honor for actions during the Battle of Hughes City. Before departure, the crew tests propulsion, navigation, communications, cranes, firefighting systems, and aviation equipment. Once clear, the ship proceeds to an operating area where embarked military units can transform its open spaces for the assigned mission. The mission deck provides space for equipment preparation and storage. Small boats can approach designated access points for personnel and cargo transfer. Crews rig fenders and lines, establish safe zones, and coordinate every movement with bridge watchstanders. Loads may be lifted by crane or moved across ramps, allowing the ESB to serve as an offshore connection between ships, aircraft, and forces ashore. Aircraft handlers guide helicopters into position, while fuel teams, maintenance specialists, and rescue personnel remain prepared nearby. During flight operations aboard USS Herschel Woody Williams, crews practiced the disciplined sequence needed to launch and recover aircraft at sea. Wind direction, deck motion, visibility, and aircraft weight all influence the approach. Heavy external loads add another challenge. During a shore-to-ship exercise involving USS Miguel Keith, a CH-53E Super Stallion carried a Joint Light Tactical Vehicle beneath the helicopter. Ground teams attached slings to approved lifting points, checked balance, and cleared the area. On deck, landing personnel directed the aircraft above the receiving point. The vehicle was lowered carefully until its tires touched down, after which crews released the slings and moved it clear. This method allows heavy equipment to reach a sea base even when landing craft, piers, or roads are unavailable. Together, LCACs, ACVs, and ESBs form connected parts of modern amphibious warfare. Hovercraft carry armor and supplies across the surf. Amphibious vehicles deliver Marines directly from ships to contested beaches. Sea bases provide the aviation, storage, command, and transfer space that keeps those forces supported offshore. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.